Today we are continuing the lesson that we started the other day with vectors in the coordinate plane. One of the things to note here is we are now transferring our knowledge that we had before to what's called a unit vector. If you look here, a unit vector, it's still giving the direction, but now your magnitude is 1. So you notice here that the length of that unit vector is 1. And so the way that you would go about doing that is you would take and you would do u equals the vector divided by the magnitude of that vector. So the previous video, the previous lesson was talking about how to find the magnitude going back using that distance formula. So the very first thing that we're going to want to do for example number 1 is using this information, we're going to want to find the magnitude of that vector. Reminder that this negative 11 indicates the horizontal amount. So we would square that. The negative 5 indicates your vertical amount. So we would square that, and then connecting it to the Pythagorean theorem, we're going to go ahead and do the square root. Rather than getting the radical, or simplifying the radical, or getting a decimal, we're just going to leave it as the square root of 146. And so, therefore, your unit vector is just each one of those components divided by that magnitude. So negative 11 over square root of 146, and then negative 5 divided by the square root of 146. So it's still going to have the same direction as the given vector, but now if we were to go back and find the length of that vector length is only going to be a 1. So you take the magnitude and just divide each component by that magnitude. If we turn our paper over and we look now at the back, this upper left-hand corner is just a notation piece. If you see the vector written like this, that is equivalent to where if you see it written like this. Sometimes they take the A times the I plus B times the J. And so when you look at your picture, the AI is still the horizontal component, and the B times J is still the vertical component. The result of that is still that same vector. So basically, all that to say this. This information is identical to this, it's just presented in a different format. Okay? If we look at the upper right here, it says if V has a direction angle of theta, the components of V can be computed by using the following formula. Now here's the deal. What I want for you to do is think about this as a unit circle. The x coordinate is your cosine, the y coordinate is your sine. The difference is this is not a 1 as it is in the unit circle. So you're going to take that V, that magnitude, and you're going to multiply it by the cosine, your x term, and the same thing, magnitude times sine, your y term. So this is going to give me my horizontal component. This will give me my vertical component. So when we look at the example below, find the components of the vector V with the direction angle of 110 and a magnitude of 5. Notice it says sketch a picture also. So let's start with the picture really quickly so you can kind of see what this looks like. If it's 110, it's going to go beyond that 90 degrees. So it's going to look something like this. And this has a magnitude of 5. So right now, we should kind of in the back of our minds be thinking that this is going to be to the left and up. So negative, positive. So when we plug this in to our formula that we have up here in the upper right-hand corner, all we're going to do is take the magnitude, so 5 times cosine of 110, and then 5 times the sine of 110. So the first one is going to give me my horizontal component. The second will give me my vertical component. So we've got negative 1.71 and vertical 4.7. That is going to be the two components for that vector, which again makes sense because I've gone left and up. Okay? If you look at the next example, this is kind of the opposite type of question as this, or as the previous one. It says to find the magnitude and the direction angle of each vector. So let's start off by kind of sketching a picture so we can see what we're looking at. We've got the coordinate plane, and we're over 12, and we're up 16. We're trying to figure out not only the magnitude, so this, but also your angle measure. Now if you notice, you have a right triangle here, and so you're going back to your right triangle trig, and you're going back to using Pythagorean theorem because you have a right angle here. So let's start off by finding your magnitude. Your magnitude is just going to be 12 squared plus 16 squared, and then the square root of that. So your magnitude is going to be 20 once you simplify that. And then the second component is finding that angle. Notice you have the opposite to the angle that we want, and and the adjacent, so we're going to be dealing with tangent. So tangent of the angle is opposite over adjacent. Make sure your calculator is in degrees, and so you're going to do the inverse tangent of 16 over 12, which is going to give you approximately 53.13 degrees. Okay, so take a second. For the second one, start by finding your magnitude. Once you find your magnitude, you should have had a magnitude of the square root of 61. And again, I'm going to have you just leave it in radical form here. Okay, your angle is a little bit tricky on this one because if you look at -6, +5, you are actually going to be over here in this quadrant, -6, +5. Now keep in mind when you're finding the angle, you're not just finding the angle here, you're actually finding the angle going from clockwise from that x-axis. So take a second with that knowledge and figure out what is this angle in that upper quadrant. So hopefully you recognize that this triangle here, you're going to be doing the tangent of theta opposite over adjacent. Go ahead and just type it in as 5 over 6 to figure out the positive angle. But then you're going to do 180 minus that angle. So I'm just going to write all this here, that way I don't forget about the decimals. So you're going to do the inverse tangent and then do 180 minus that, and you would get an angle measure of 140.19 degrees. So as you look at this, that is kind of the basics of day 2. Obviously, I anticipate that there are going to be some questions because this is a little bit new, especially when you're looking at this last question, maybe where that angle measure came from. Please let me know how I can help. Other than that, that is it. Thank you.